Energy from Heat and Light by L. L. Owens. Transferring Thermal Energy. Thermal energy. Thermal energy is the total kinetic and potential energy of the particles in a substance. If you could see the particles in steam, you would see that they move quickly. The particles that make ice might not appear to be moving, but they are. In fact, all matter is made up of particles that are always moving. The energy that results from the movement is called kinetic energy. Particles in a solid have a small amount of kinetic energy. That energy causes them to vibrate, but the particles cannot move from their fixed position. Particles in a liquid have more kinetic energy. They can flow around each other. Particles in a gas can move freely. They have even more kinetic energy than particles in a liquid. Particles in a substance always pull on each other. They have potential energy, which is stored energy due to position. Thermal energy is affected by temperature. A cool cup of water has more potential energy than the same size cup of warm water. The warm water has more kinetic energy because particles move faster at a higher temperature. Heat. If you have ever taken your temperature, you've measured your own kinetic energy. A thermometer measures the average kinetic energy of particles in your body, which is your temperature. Temperature and thermal energy are not the same thing. Recall that thermal energy is the total kinetic and potential energy. Temperature is a measure of the average kinetic energy. It does not depend on how much of a substance there is. Heat is the transfer of thermal energy from one substance to another. It always moves from a warmer substance to a cooler one. When something gets warmer, that means thermal energy has moved into it. You see this when you toast a slice of bread. The energy from the toaster moves into the bread and warms it up. It causes the average kinetic energy of the bread's particles to rise. Conduction. There are three types of transfer: conduction, convection, and radiation. Conduction is the transfer of thermal energy between two objects that touch. An example is ice cubes dropped into a glass of water. The water has a higher temperature, so its particles are vibrating faster than those in the ice. When the cooler ice touches the warmer water, the water's particles bump against the particles in the ice. The ice particles start moving faster. Energy transfers from the water to the ice. Conduction has made the water cooler and the ice particles warmer. Conduction does not cause the particles in the substances to change location. Instead, energy moves from particle to particle. This happens as the particles bump against each other. It can occur between a warmer object and a cooler one. It can occur between the warmer part of an object and a cooler part of the same object. Convection. Thermal energy can also be transferred by convection. Convection is the transfer of thermal energy by the movement of a fluid. A fluid is any gas or liquid. When fluids are heated, they become less dense. This causes warm fluids to rise above cooler, more dense ones. Cool fluids sink. When warm fluids rise, they carry their thermal energy with them and can then transfer that energy to other materials. The rising and sinking of fluids often occurs in circular patterns called convection currents. Huge convection currents are generated in Earth's atmosphere, causing wind. Warm land transfers thermal energy up into the atmosphere. There, energy is transferred to the cooler surrounding air. When the air cools enough, it sinks back to Earth. It rushes in under other air that is being heated by the land. This cycle happens over and over again. Crocodiles are cold-blooded and need to absorb energy from the sun. Radiation. Radiation is the transfer of thermal energy as waves. This transfer can happen through matter or across empty space. In the picture above, energy from the sun warms the crocodile through radiation. Solar energy travels to Earth through space. Some solar radiation is absorbed into Earth's surface. The absorbed radiation causes Earth's surface to become warm. Some solar radiation is reflected back toward space, but gases in the atmosphere can also cause it to be reflected back to Earth's surface again. This is known as the greenhouse effect. The greenhouse effect is crucial to the survival of life on Earth. Without it, Earth would be cold and lifeless. Scientists study whether the greenhouse effect causes such gases as carbon dioxide to trap too much radiation. The concern is that the unnecessary radiation makes Earth's climate warmer. Insulation. The process of insulation helps stop or reduce energy transfer. A heavy winter coat acts as an insulator because it is made of material that does not easily transfer thermal energy. It can help keep you warm on a cold day. On the other hand, a metal flagpole will feel very warm when it's hot outside. Metal is a conductor, so it easily transfers thermal energy. Let's take a closer look at insulators and conductors. Remember that particles in a warmer object move faster than particles in a cooler object. What happens if the two objects touch? The particles in the warmer object bump against the particles in the cooler object. This causes the particles in the cooler object to start moving faster. The kinetic energy rises. Conduction causes the temperature of the cooler object to rise. Silver and copper are two metals that are good conductors. Electrons in these metals are not tightly held to the atoms. These electrons can move easily. They can carry energy from place to place. If you have ever felt the handle of a metal spoon that is in a bowl of hot soup, then you have experienced conduction. The handle feels warm because thermal energy from the hot soup was transferred into the spoon, and when you touched it, heat moved into your hand. If the particles of a material do not easily transfer energy, that material is an insulator. The particles in fluids are farther apart. This makes fluids better insulators than solids. Empty space is another example of an insulator. Energy can only move through empty space by radiation. Use of insulators. Insulators are an important part of daily life. You may put extra blankets on your bed if it is cold. Layers keep you warm. Air is a good insulator, so the pockets of air between the layers keep you warm. Animals living in cold climates have their own insulation to help them get through the harshest conditions. They may have thick layers of fat or fur that trap thermal energy and keep it close to their bodies. Insulation helps buildings stay at a comfortable temperature. You may have seen insulating materials such as fiberglass, carpet, double-layer windows, and foam used in your own home. The many layers of insulation contain air pockets that slow the movement of thermal energy out of the home. This is important on cold winter days. In warmer weather, the insulation keeps thermal energy out of the house. How waves carry energy. Kinds of waves. Many types of energy move in waves. There are two main types of waves, compressional and transverse. Both move through matter, but they do not carry the particles of the matter along with them. In compressional waves, the particles move back and forth, like the folds of an accordion. In transverse waves, they move up and down, like a cork bobbing on an ocean wave. Vibrations cause all waves, including sound waves. Sound is an important type of compressional wave. Have you ever seen someone use a tuning fork? It's made up of a handle and only two tines or teeth. When you strike the tuning fork, the tines vibrate and produce a specific pitch. Striking the fork causes its molecules and the surrounding air to vibrate. The vibrations move outward in all directions through the air. When they reach your ear, you hear a sound. Sound waves can travel through matter, but they can't travel through empty space. Electromagnetic spectrum. Light travels as a wave. Unlike sound, light can travel through empty space. One of the many types of waves that travel from the sun to the earth is visible light. Wavelengths can be long or short. The electromagnetic spectrum is the pattern that you would get if you arranged all types of waves from the shortest wavelength to the longest. As wavelengths become longer, frequencies become lower. A shorter wavelength indicates that a wave has more energy. Light absorption. If you were to shine a flashlight on a window, would the light travel through the glass? Yes. Would the same light travel through a metal door? No. Light reacts differently when it travels through different types of matter. Some light is taken in or absorbed by matter. Some of this light energy is converted to thermal energy. Dark-colored materials absorb more light energy than light-colored materials. A black car sitting in hot sunlight will feel warmer than a white car will. Darker objects absorb more light energy and convert it into thermal energy. Almost all light passes through transparent materials, such as glass and water. Less light passes through translucent materials, such as wax paper. No light passes through opaque materials, such as rock and metal. The speed of light is 300,000 kilometers per second. That's the speed at which all electromagnetic waves travel through empty space. Light travels through matter at slower speeds, and those speeds vary. Light travels the fastest through gases. It moves slower through liquids and slowest through solids. Refraction. Refraction is the change of direction of light as it moves from one material to another. Light changes speed as it moves through different materials. If a light beam strikes the border of two materials at an angle, this will change the speed. The change in speed then changes its direction. An example of refraction is when a ray of sunlight hits a glass prism. The light is made up of various wavelengths. It appears to be colorless. But when it enters the prism, the light changes direction. The different wavelengths refract at a variety of angles and give off a rainbow effect. In fact, that is exactly what happens when it is raining and the sun comes out again. Where it is still raining, some of the raindrops act like little prisms. Light from the sun refracts at various angles, and you can see a rainbow. Reflection. The bouncing of light rays off a material surface is called reflection. Reflection happens when light does not pass through a material and it is also not absorbed. A mirror's smooth surface allows light to reflect back so you can see your image or your reflection. You can also see your reflection in some other smooth surface materials. Surfaces, such as walls, tabletops, and book covers, appear to be smooth but do not reflect well enough for you to see a reflection. If you look very closely at them, you will see that their surfaces contain bumps and holes. Light bounces off these surfaces in many different directions. For you to see your reflection, a surface must be so smooth that light bounces back to your eyes. The color of things. Have you ever thought about why you see things in color? The color of any object depends on the wavelengths of light that it absorbs and reflects. A black object absorbs almost all the light that hits it. When you look at a black bowling ball, very little light reflects back to your eyes. White is made up of a combination of all wavelengths of light. This white dog reflects almost all of the light that hits him. When you look at a red apple, you see the red light that reflects off it. Red objects absorb all light wavelengths except red. Green objects, such as this clover, absorb all light wavelengths except green. That means they reflect the green wavelengths of light. These blue gloves reflect only blue wavelengths of light. All other wavelengths of light are absorbed.